We talked about section 6.1 last time. Now today we are going to look at section 6.2, and this section talks about multiplying and dividing rational expressions. Now in the last section we had talked about how to write expressions in lowest terms, and we looked at how to write equivalent forms and stuff. Now we are going to look at how to multiply rational expressions. That's the first thing we're going to talk about. So let's go ahead and start with multiplying rational expressions. Now here we are giving you the definition. Basically, when you have two rational expressions, p over q and r over s, when you take the product of these two rational expressions, you should end up with p over q times r over s, which will give you p times r over q times s. Okay, so we will go ahead and get started with this example. Now again, remember, since we are dealing with rational expressions, you always want to write your final answer in lowest terms. Keep that in mind. So let's look at this example here. You have 27k cubed over 9k times 24 over 9k squared. So if you are going to try and multiply these expressions together, you should end up with, let's see, you can try and reduce this in the first step itself. So we have 27 times k to the third over 9 times k. On the other side you have 24 over 9 times k squared. Now you can see that you can reduce the 9 and 27. Both of these numbers will go into 3. So we can reduce 9, which will be 3 times 3 is 9. 27 is 9 times 3. Or you could have also tried and reduced this as 9 into 1 and 27 into 3 times. Now you can reduce the 9 and the 9 here. Okay, so you can see that we got rid of the 27 and the 9 here, and of course the 9 on the other side. Now let's see, what else are we left with? We're left with 3 here and a 24 over there. 3 will go in itself once. 24 will go into 3 8 times. So basically on the numerator we are left with 8. On the denominator we're left with 1 as far as the numbers are concerned. Now we can try and see what happens with the variables. You have k to the third on the numerator. You have k and k squared on the denominator. Now if you look at this, you are left with k to the third here. Denominator k squared times k is also k to the third. So k to the third and k to the third can also cancel each other out, and all that you are left with is 8 over 1, which of course is just the value 8. So when you're really multiplying rational expressions, you're multiplying them, but at the same time you are trying to reduce them and put them in the lowest terms. Now if you like, you could have tried to multiply the 27 into 24 and then the 9 into 9 and then go ahead and put it in the lowest terms, but it's just really hard that way because you're dealing with much more larger numbers. This way you are trying to get rid of all the large numbers and make it as easy as possible. And so the product of these two rational expressions is going to be the number 8. All right, now let's go ahead and take a look at another example here, just something different. You have t minus 2 quantity squared over 4t squared times the rational expression 2t over t minus 2. So we want to do a similar sort of thing that we did in the first example, and let's go ahead and see what all we can reduce and then go ahead and find our product here. So you have t minus 2 quantity squared on the numerator. Denominator you have 4 times t squared. If it makes it easier for you, you can go ahead and break the t down into t times t On the other side, you have 2 times t over t minus 2. So you can see that you have t minus 2 and a t minus 2 common between your numerator and denominator. You can go ahead and cancel that out. You're left with t minus 2 here, and then on your denominator you have a t and another t over here that you can cancel out. So these two t's can cancel out. Then 2 will go in itself once, 2 will go into 4 twice. And let's see, looks like those are the only common factors we could have canceled out. So you're left with t minus 2 on the numerator. T minus 2 times 1 is t minus 2. And then on the denominator, we cancel this guy out. You're left with the 2 and the t on the denominator, and that will be your final answer, t minus 2 over 2t. Now you cannot cancel the t's or the 2's here, because here you have t minus 2, and on the denominator you have t times 2. You just cannot cancel them. They're not the same terms, so this will be your final answer. So as you can see, multiplying rational expressions is, you start out by reducing them, and then whatever is left, you go ahead and multiply those terms together. All right, we'll look at a couple more examples, just different types of examples. Now here you have 8r plus 16 over 24r minus 24 multiplied with 6r minus 6 over 3r plus 6. So again, that's the same thing you're trying to do here. You're going to try and cancel out all common factors. But unlike our first two examples, in this one, you will have to factor out any common factors that you have, greatest common factor, and then you can go ahead and try breaking these down. So let's look at our first term here in our numerator. You have 8r plus 16. If you look at 8r and 16, you can see that the number 8 is common between these two terms here. You can pull that 8 outside as your greatest common factor. So when we take that 8 outside, you're left with the r. And then from 16, if you take 8, which means that if you divide 16 by 8, you are left with 2. Okay, so you pull the greatest common factor outside. You'll do the same thing for the other three terms here. So looking at our denominator, you have 24r minus 24. So again, you can see 24 is common between both these terms here. We'll pull that 24 outside, and you're left with r minus 1. Because again, you're left with the r from the first term, and 24 divided by 24 is just 1. So same thing on the other side, 6r minus 6. 6 is your common factor between the two terms, and you are left with r minus 1 over here. Again, 6 divided by 6 gives you 1. That's where that 1 comes from. In the denominator here, you have 3r plus 6. Between 3r and 6, you can see 3 is your common factor between those two terms. Pull the 3 outside, and you are left with r plus 6 divided by 3 gives you 2. Okay? So once you pull your greatest common factors out from each one of these terms here, now you can go ahead and try and see, okay, what are my common terms, which ones can I cancel and reduce them down? So we will start with, you can see r plus 2 and r plus 2. You can cancel those out. You're left with r minus 1, r minus 1. So again, you can go ahead and reduce those down. Now you have 8, 24, 6, and 3. Among these numbers, now again, you can try and see, okay, which ones can I cancel out, which ones I can reduce, and go ahead and do that. Now 8 and 24, you can cancel both of these by 8. 8 will go in itself once. 8 will go into 24 3 times. 3 and 6, 3 will go in itself once. 6 will go into 3 twice. And let's see, what are you left with? We, of course, canceled out all our parentheses here. 2 times 1 is 2. And and then you have on your denominator you have 3 and 1, so 3 times 1 of course is 3, and that will be your answer. 2 over 3 in its lowest terms will be the answer for this rational the product of these rational expressions here. So you can see how well these products clean up. They usually end up being something pretty simple here. Alright, let's look at one more example before we move on, and this example involves again factoring before you can start canceling out your common factors. So you can see that each one of these are second degree polynomials here. So you will have to go ahead and factor each one of these terms out before you can reduce them. So let's look at z squared minus z minus 6. Now remember, this will factor out into two binomial terms, okay? And you will have, let's see, you have negative 6 as your last term. Your first term is z squared, and again you can see your coefficient on z squared is 1. So this tells me my first term for my binomials is going to be z and z. Now, when you're factoring terms of this form, trinomials of this form, you look at the last term of your trinomial, which is a negative 6, and you try and find factors of negative 6, which will of course multiply to give you negative 6, but when you add those factors, they will give you negative 1, which is the coefficient of your middle term here. You have to be, you have to keep that in mind when you are factoring trinomials of this form. So again, we started out by looking at our first term, which was z squared. You didn't have any coefficient here, which means it's a 1. So your first terms in your binomials here are going to be z and z. Then you look at the last term, which is negative 6, and try and find factors of negative 6, which multiply to give you negative 6, but add up to give you the coefficient of the middle term, which is negative 1 right here. So factors of negative 6 will be negative 3 and positive 2. Negative 3 and positive 2. Think about it. Negative 3 times positive 2 gives you negative 6. When I add negative 3 and plus 2, I end up with negative 1, which is the coefficient of my middle term. So that's what I'm looking for, okay? You will apply the same idea to factor all the other terms here. This one, of course, is difference of squares, which we talked about in our review section. So we have, let's see, our denominator here is z squared minus 2z minus 8. So again, your first term is z squared with a coefficient of 1, which tells me that again, my first two terms, or my first terms in each binomial is going to be z and z. Just like we did in the example above, you look at negative 8, your last term, and try and find factors of negative 8, which will give you negative 2 when you add them together. So you have negative 8 would be 4 times 2, but we want negative 8, so how about negative 4 and a positive 2? So when we multiply, you get negative 4 times positive 2, which is negative 8. When you add negative 4 and 2 together, you end up with negative 2, which is the coefficient of your middle term. So we know this will work for us. Alright, moving to the other side, you want to do the same thing. You will factor your numerator. Again, your leading term is z squared, and it has a coefficient of 1, which tells me these two terms here are going to be again z and z. Looking at our last number here, you have 12 as the last term. So factors of 12, which will add to give us 7. Let's see, 12 would be 6 times 2, but 6 and 2 do not add up to give us 7. 4 times 3. 4 and 3 would give us 7. So we will go ahead and use positive 4 and positive 3. As you can see, 4 3s are 12. Plus 4 and plus 3 will give us plus 7. So you can go ahead and factor out your numerator that way. Your denominator, you can see, is a difference of squares, because I can write this as z squared minus 3 squared. I can write my 9 as a 3 squared, And since this is a difference of squares, I can go ahead and apply my formula for difference of squares, which would be z plus 3, z minus 3. Okay? So that's the idea that I'm going to use here to help me out. So again, let's take a look at this. Now that we have everything factored out, you can go ahead and cancel any or all of the common terms that you have. So let's start with z plus 2 and z plus 2. The two common terms you can cancel out. What else do we have? Z plus 3 and a z plus 3. Let's see, you have a z minus 3 here and a z minus 3 there. As long as one term is on the numerator and others on the denominator, it really doesn't matter on what side of the multiplication sign they are on. Now, after we cancel all the common terms, let's go ahead and see what we're left with. On the numerator, you're left with z plus 4. And on the denominator, all you're left with is z minus 4. And this will be the product for these rational expressions here. Z plus 4 over z minus 4 is going to be your answer to this example here. So you've looked at 4 different examples, and you can get a pretty good idea of how you are supposed to multiply rational expressions and how to put them in lowest terms.